Hello grade 12s, welcome back to another exciting video. So on today's video we'll be doing vertical projectile motion. If you're struggling with momentum and impulse, please check my previous video that I uploaded last week Wednesday. Check that out so that you can ace these exams. I've also covered organic chemistry, so I covered it and the videos were done in January, so you can check. I did everything with regards to organic chemistry and also the reactions of organic chemistry. Hello guys, thank you for coming back. If you are a subscriber, and sorry if you are here for the first time, welcome and I hope you stay. If you find this video, this information useful, please share it with your friends and family. Now, without wasting any more of your time, let's get right into it. So here we have an extract from the examination guideline. What does the examination guideline say about vertical projectile motion? So it's very important that with physical science you have your examination guideline. Just go on Google, type physical science grade 12 examination guideline PDF, and after that you'll be given a PDF, the examination guideline in a PDF format, and you download it to your phone so that every time you are studying you can just refer to it, because having an examination guideline will help you to be able to answer questions like the true or false questions. Not the true or false, sorry, we only have multiple choice. Yeah, you'll be able to answer multiple choice and you'll be able to ace your multiple choice question. So make sure that you do that. So vertical, you need to know what is meant by projectile. It means an object upon which the only force acting is the force of gravity. So use equation of motion to determine the position, velocity, and displacement of projectile at any given time. You need to be able to sketch graphs for position versus time. So x versus t, velocity versus time, and acceleration versus time for each of the following: a free falling object, an object thrown vertically upwards, an object thrown vertically downwards, a bouncing object restricted to balls. For a given graph for position versus time, or acceleration versus time, and you need to be able to determine position, displacement, velocity, or acceleration at any time. So for given position versus time or acceleration versus time graphs, describe the motion of the object for the following: bouncing, thrown vertically upwards, and thrown vertically downwards. So here you're going to talk about something that is thrown. Maybe you are standing, you are at the bottom, you are throwing a ball upwards, or you're standing at the top and throwing a ball downwards. So and maybe when the ball gets on the ground, it pitches, okay, it bounces certain times. So that's how that's what this whole topic is all about. You did a similar one in grade 10, which was motion in one direction. So you can ask a grade 10 learner to borrow you the textbook and just be able to go through motion in one dimension. So you need to know vertical projectile motion definitions and concepts. You need to know acceleration, average speed, average velocity, displacement, distance, frame of reference, speed, velocity. That's you have to know. This is a prerequisite. So this one, that is motion in one direction, it's a prerequisite. So it's something that you have to know before you do projectile. So you need to know motion in one direction from grade 10 before you do vertical projectile motion. So in grade 12 you need to know what is a projectile and a free fall motion. Okay, so those are the things you have to know. So make sure you have your examination guideline, and yeah, let's get right into it. So for motion in one direction, we use this formula the new ones, so don't mind the old ones. This is how they were written, the old syllabus, but now with caps, the one that you're doing, we use this one's the new formula. So VF is final velocity, VI is initial velocity, A stands for acceleration, and then that is change in time. The T is time. So when we have x is displacement. Okay, so that is the only thing that you would not know on this. With the x stands for displacement, so you know everything. If you're looking for final velocity and you have initial velocity, acceleration, and time, you can use the first one. If you're looking for displacement, you use the second one, depending on what you have. So you have to be able to know how to use your formulas. You're in grade 12, so I don't think it's a problem applying formulas. But one thing that you have to know again, it's that when you are given formulas in a test, stick to the formulas that are given to you in the test. Do not bring another formula that you know that the examiner did not include in the formula sheet. Okay, even if it's part of that, the questions are structured in a way that you will be able to answer every question using the formulas. Okay, they might ask for the longer way around, but you can be able to answer any question using the given formulas. So steps to using the equations is to draw a diagram of motion of the object, identify each stage of the motion, where the acceleration has changed, choose a positive direction and use the same conversion throughout. Record the information given and the value required by writing next to each variable. Check the unit and direction, and then select the correct equation and solve for unknown. So you need to have a clear understanding of the scenario that you have before you calculate. So you must draw and make drawings to be able to know, to be able to understand a statement before you make calculations, so that you know exactly what you have and what is needed. So include units and direction in your answer. So remember, starting from rest means initial velocity is 0, and then it comes to a stop means final velocity is 0. Slowing down means acceleration is negative while moving in a positive direction. Okay, so slowing down means acceleration is negative. Constant velocity means acceleration equals to 0. Let's do this. Yeah, so or initial velocity equals to final velocity with constant velocity. So the car is moving at a constant velocity. It does not accelerate or decelerate. Use a new set of variables for each stage of the motion. Conversion of units, 1 meters per second equals to 36 kilometers. So when you are given kilometers, you divide that kilometer. If you're given 60 kilometers per hour, you divide it by 3.6. Always velocity should be in meters per second, and your mass should be in what? Kgs. If it's grams, you divide by 1,000, they give you kgs. So always do that. You can watch my previous video. I explained a whole lot there with momentum and impulse, because these two topics go together. A racing car starts from rest on the grid. So there's a car that starts at rest, meaning it starts at a car that is not moving, and then the person turns on the car and starts moving straight along the track and reaches and they go for 400-meter mark after 8.6 seconds. So the question says, what was its average acceleration? Let forward be positive. So the car is traveling on a straight line. So you can either this when it reverses, it will be you can choose it as left, and then the straight no, backwards is negative and then positive is forward. So what is the average acceleration of the car? One thing that you have to remember is that displacement is distance. We're talking about distance, acceleration. Speed is velocity. Okay, that's what you need to have. So let's go back to the formula. We have displacement x, we have time, those are the two things that we have displacement as 400 meters, we have time as 8.6 seconds. Time should be in seconds always. And then we have the car starts from rest, so meaning we have initial velocity as 0. So we have initial velocity, displacement, and time. So we are looking for acceleration. Don't mind the averages and all that. You are looking for acceleration. So you're going to go to your formula sheet and ask and see, how can I get acceleration from the information that I have? So we only have initial and not final velocity. That's why in that question they used formula number 3. You see, this one, that's change in x equals to da 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 da. They use that one because they have everything that is in that formula. You don't have final velocity, so you avoid anything that has final velocity. Or what you can do is first try to find final velocity with what you have, and then you can use any formula that has final velocity that can help you find acceleration. Okay, if it's even possible, you can do that as well. So here we are. In this instance, you are solving for a, so which means 0 times 8,6 will go to the left hand side and be negative, but the whole thing is going to be 0 anyway. So, and then you can solve this one. Okay, here you solve for a, and then for b, what is the velocity at the what was its velocity at 400 Mach? So we're looking for final velocity here. I hope you understand how you answer those type of questions and how do you use those formulas. So graphs of motion, for motion on a horizontal plane. So this is a position versus time the graphs on the first block, and then the middle one is velocity times time, and then the third one is acceleration versus time. So with position versus time, the line is straight. When we are dealing with when the object is stationary, velocity equals to 0 meters per second. So when the object is stationary, velocity equals to 0 minutes per second. And this is how is it for velocity, time graph, acceleration, and position. And then the object is moving at a constant acceleration. This is how it is for the different for the different time versus position, velocity, and acceleration. So at the bottom we have time, and then on the left hand side is either we had position, velocity, or acceleration. So if the object is moving at an increasing velocity, this is how it is. So if the object is moving at a decreasing velocity, constant non-zero acceleration, so this is how the graphs look. Let's look at the displacement time graph here. So at number 1 is positive acceleration, and then at number 2 we have constant velocity, and then number 3 is a negative acceleration. 4 is just a straight line. We are at rest. So gradient is the gradient of velocity is area below graph is not available. So I hope you understand the displacement time graph. The more you start from a positive acceleration to a constant velocity at 2, and then a negative acceleration at 3, and then you're at rest at number. Yeah, so the velocity time graph, I'm going to link a grade 10 video of this velocity and displacement time graphs in the description box down below, so please check them out. I've recorded them already, so I will just be linking them for you guys so that you can go back to them so that you understand these graphs. Okay, it's very important that you do this. A prerequisite, you need to know the grade 10 work before mastering grade 12. So I'm just going to leave the link in the description box. It's a detailed video. So with velocity versus time, at 1 is positive direction, positive acceleration. At 2 is constant velocity. And then at 3 it's negative acceleration. So at 4 you are at rest. And then gradient is acceleration. Area below the graph is displacement. So the gradient of this graph is acceleration, and area below the graph it's displacement. So yeah, let's look at acceleration time graph. 1 is a positive acceleration, 2 is a constant velocity where acceleration equals to 0, 3 is a negative acceleration, and then 4 is the rest. So the negative acceleration, it means that the person is going into opposite direction. So let's look at this. Vertical projectile motion explained. So a projectile is an object that moves freely under the influence of gravity only. It is not controlled by any mechanism, pulley, or motor. The object is in free fall but may move upwards, thrown, or downwards. So it's something that you can just throw up and down. That is a projectile. So anything that you can just, like a stone, just throw it up and it comes down, that is a projectile. Okay, a ball or whatever that you can throw up and it can come down, or you can throw it from high and throw it down. Forces on a projectile. In the absence of friction, the gravitational force of the earth is the only force acting on a free falling body. I hope you remember this from grade 11, Newton's law. You still remember your diagrams. This force always acts downwards because the gravitational force is always downwards. A projectile that is moving upwards must slow down. When a projectile is moving downwards, it moves in the direction of the gravitational force. Therefore, it will speed up. So when the projectile is moving downwards, gravitation is trying to put something down, right? So when you're throwing something, when you're high and throwing it down, it moves at a high speed or velocity than when you are at the bottom throwing it up. So anything that moves in the same direction as gravitational force will speed up, so its velocity will be higher. So if I am throwing something up, and then when it reaches a certain point up, it goes down, it means initial velocity will be higher than final velocity will be higher than initial velocity. But if I am upwards throwing a ball downwards, the initial velocity is higher because it will get to the ground, pitch, and then go up. So initial velocity will be higher than final velocity. Acceleration due to gravitation. All free-falling bodies have the same acceleration due to gravity. So the acceleration is 9.8 meters per second downward, ignoring air resistant friction in a marble and a rock are released from the same height at the same time. They will strike the ground simultaneously and their final velocity will be the same. Their momentum and kinetic energy are not the same due to a difference in mass. So final velocity of two objects can be the same, but their momentum and kinetic energy can never be the same because of they have different mass. If two objects are released from different heights, they have the same acceleration, but they strike the ground at different times and have a different velocity. So know that if I'm throwing two things from upwards, throwing them down, they have the same acceleration. I hope that is clear. So this four formulas are still gonna work. Please know them by heart. It's very important that you do, and you know that y or x is displacement in meters, t is time, initial velocity, final velocity, and acceleration, as I've said. So make sure you know this. Make sure. So remember, here it's a reminder: draw a sketch diagram, write down the given variables, choose a positive direction, and then solve. So parts of a projectile path. The path of projectile motion can be analyzed using the four section. As shown below, the combination of these four parts will depend on the actual path traveled by the projectile. So let's look at this. A dropped projectile will fall into section C and D only. A projectile thrown upwards that falls on a roof will fall into section A and C. So whenever you're throwing something up, it will go as if it's going backwards. It will go backwards from where you are throwing, so it does not go on a straight line. AC is backward. As you can try to throw something up now, you will see it will not go straight, it will go a little bit behind you. So that's what is meant here. So let's look at this quickly before we can look at calculations. Parts of a projectile. So in an example below, ABC and D refer to the graphs in section 5.2.1 above. So objects dropped from height. If you're dropping an object from height, number one is the position versus time graph. This is how it will look like. And then the velocity versus time graph. If anything is dropped from a height, this is how it will look. And acceleration versus time graph, this is how it will look. That's number three. And when the object is thrown down from height, yeah, it's still when it's thrown high from let's look at I think we'll need to look at 5. Yeah, this is the 5.2 that we just looked at. Now we'll look at the graph. This is how the graph is when you are dropping from height. This is how it is. They are exactly the same. And then for object thrown up, this is how you do it. So this is a position versus time graph, velocity times time graph, and then acceleration versus time graph. So this is how the graphs will look like. So this is how the graph will look like if an object is thrown up and caught. It's not going to the ground. The person, you just taking the ball up and you're going to catch it when it comes down. This is how they look like. This is for the object that bounces when it gets to the floor. So this is position versus time graph, velocity times time graph, and acceleration versus time graphs. In the collision is perfectly elastic. The downward velocity before the bounce and the upward velocity after the bounce are equal in magnitude. Please treat two projectile paths before and after bounce as separate paths. So please guys, watch the one that I did previously with impulse. It will help you a lot to understand a whole lot of things here. Okay, now let's look at this question. This is a possible exam question. A stationary rocket on the ground is launched vertically upwards. After 4 seconds, the rocket's fuel is used up and it is 225.6 meters above the ground. At this instant, the velocity of the rocket is 112.8 meters per second. The diagram below shows the path followed by the rocket. Ignore the effects of air friction. So here we see, so write down the direction of the acceleration of the rocket at point P and Q. The direction of the acceleration of the rocket is upwards. This rocket is going upwards. So that is the direction of the acceleration. Though 2.1.1, 2.1.2, the acceleration, direction of the acceleration of the rocket is upwards. Yeah, sorry, for P it's upwards. They said if you write, if we read this statement correctly, they said after the rocket's fuel is used up and it is 225 meters from the ground. So at Q, this rocket is now a projectile. It means it can go down at any minute. There's nothing, it has run out of fuel, so the fuel that will keep it to go high for as long as the person who is controlling it wants, it can now come down at any moment. So at P, the direction is still upwards, vertically upwards at P, but at Q it is now a projectile. It is now a projectile, yes, because the fuel has been used up. So at Q is only moving toward because of gravity. Yeah, so it's the thing is the rocket is only moving due to gravity. And at Q, acceleration is downwards. Now 2.2, at the point of P or Q, is the rocket in free fall? Give a reason for your answer. So the only force acting on the object at Q is force of gravity. So at Q, it's force of gravity that is acting on the rocket. Okay, and then 2.3 says taking up what motion as positive. Use equation of motion to calculate the time taken from the moment the rocket is launched until it strikes the ground. So let's look at what we have. After 4 seconds, the rocket fuel is used up, and we have the time. 4 seconds, we have displacement. This is the displacement when the fuel is used up, so that would be negative 225.6 meters above the ground. And then we have a velocity of 112.8, which is positive, that is the velocity. And then yeah, so we have initial velocity, we have displacement, and with and then we have acceleration due to gravity. So our acceleration will be 9.8. Remember, in the formula sheet you are giving it as 9.8 is acceleration due to gravity. So what we are trying to calculate here is calculate the time taken from the moment the rocket is launched until it strikes the ground. So you have to using the motions, so you need to look for a formula there. We can see if we can't first find final velocity. Let's look if we can find final. So we can actually find final velocity. We have initial velocity, we have acceleration due to gravity, which is 9.8, and no, we are looking for time, so we can't use that one. We can use the second one. Yes, let's use the second one. We're looking for final velocity, which is vf squared equals to vi squared. So we have initial velocity as 112.8 meters per second, and then we have acceleration, which is 225.6. no, acceleration is 9.8, sorry, that is a constant, and then displacement, which is y, is 225.6 meters. So we have that. We can find the final velocity so that we can find the time. Do you see, guys? This is how you make use of these formulas. So this is how we will write everything. So our final velocity is there. Up is positive. So after the fuel has been used up, it's a negative direction. Okay, so it's that's why we have negative 225.6. That's why it's negative, because we say from, is it q, it's p, yeah, q, it's now a negative direction. So that is why we have that. Now calculate the time taken, then add the 4 seconds for the first part of the journey. Now we have final velocity. Now when we have final velocity, we can try to calculate time. We go to the formulas to find the formula that we can best use to calculate change in time, and this is the one that is best. So we have the change in time. So total time taken, we add the time that we just calculated plus the 4 seconds and have 28. I hope you understand this answer. You just have to get your calculator and get working. That's how you will understand everything that just happened here. And then 2.4, we are asked to draw. The fuel is used up. The rocket is a projectile. The rocket, when the fuel is used up, you're asked to draw this graph when the fuel is used up. So the rocket is now a projectile. Thus acceleration is constant, and the graph must be a straight line with a gradient equals to acceleration of negative 9.8 meters per second. I hope you understand this. I'll try to find other questions that we can do, but for this video, thank you very much for watching. Until the next one.